familiar names, but for those who don't know me, my name is Abad Banda, and I'm a tech enthusiast. Yeah, I think I haven't really joined much of these sessions lately, but yeah, otherwise, welcome me. So yeah, today we are going through storage services, and please don't hesitate to ask questions wherever you feel like you need clarity. So, in preparation for your AWS certified, so solutions architect associate, I think it's something, yeah, C03, you are expected to know the different storage services in AWS and understand where each and every one of those storage services is actually applicable. So it can be a bit tricky considering that they all sound the same, and because the idea or the concept of storage in our minds usually leads us towards the idea that there's probably like one type. But yeah, there are a number of considerations that you need to make when it comes to storage in AWS. We saw most of these in when we're doing our cloud practitioner. So what we'll do is we'll quickly go over some of the basics and then just see how much we remember. So I don't know how if people usually volunteer or I have to call them out, but you probably have to be my guide. But I'll take three volunteers, right? One volunteer will tell us what they remember about block storage and probably just simplify it as much as possible. The other volunteer will tell us about file storage. And then the last volunteer will tell us about object storage. And then from then on, we can see how we tackle this whole storage issue in AWS Cloud. So yeah, I see 5 people minus Pauline, 5 people. So Jacob, Samuel, Rodney, Kevin, Isaac. Um, I think you may take the floor, or whoever is willing to go first. You can choose whichever one you're comfortable with. Yeah, Jacob, I see you're unmuted.
Okay, cool. So I will start with block storage. So block storage is used when you're looking at scenarios where you need to store data that can persist. Usually, if you look at things like EBS, or if the scenario where you would have data that is stored in blocks, so that's where block storage can come in. So use cases can be for databases. What other things can I use block storages for? Instances like the root volumes should be EBS. So those are the use cases where block storage can come in handy. Thank you.
Thank you very much, Jacob. Isaac, I saw you unmuted as well. You can choose one and then you take us through it as well.
Yes, all right. I can look at the file storage bit, whereby the file storage it's about providing a scalable, elastic, fully managed file system for use with the given AWS cloud services and on-premises resources. So it can be mounted on multiple EC2 instances. So if you look at the key features, if we were to look at the key features of the file storage, first of all, as mentioned earlier, it is elastic and scalable. That is, it automatically grows and shrinks as you add or remove files. Then it also provides a platform for shared access, and also it's a fully managed system. Among its use cases, you can look at big data analytics, machine learning, backup and disaster recovery, and also application development and testing. So that's the brief about file storage.
Thank you very much, Isaac. And the last person will just take us through object storage. The last person who isn't Isaac or Jacob, by the way. If you're here with us, Samuel, Rodney, or Kevin, either. All right. Hello, Samuel.
Yeah. Morning, Albert. What can I say about the storage is storage, like for example the object storage. Object storage have give us an ability to store as much as like 5 terabyte, and as minimum as zero, from 0 to like 5 terabytes. So it gives us the ability to be able to had more protection on our object, and also give us enough space in order to be able to to store as much as what we need to store. So it gives us the ability to be able to secure by encryption and all this security, had more security, and it gives us the ability to be able to add use some other services in order to monitor and secure our objects that are stored in the in our storage. So, and give us the ability to be able to categorize. You can be able to even choose to be able to categorize your object that you store in your object, and be able to identify them. So what more can I say? Yeah. Yeah, that's what I could say for now.
All right, all right, all right. Thank you very much. Thank you very much. So yeah. Yeah, so as Samuel said, as Jacob said, as Isaac said, or Isaac. Okay. So as everyone else shared their bit, the thing about storage in AWS cloud is that you have to be able to build a sort of mental model, and that's what we are trying to do, right? Build your mental model in terms of um yeah, build your mental model in terms of where would I apply this particular storage, right? So it's basically you pivoting from, all right, I know what block storage is, I know what file storage is, I know what object storage is, but the fact of the matter when it comes to architecting is yeah, I'm recently learning a lot about what do you call this types of roofs, right? So you learn about these roofs, roofing materials, for example. Some are made of slab, some are made of iron sheet, some are made of hay. And then basically, as an architect, in that case, you choose to say maybe in hot climates, something like metal sheets may be better than maybe in warmer climates, you may be looking at a slab, or maybe in very, very cold climates, look, you're looking at something completely different. So that's a whole niche of architecting. And we take that particular line of thought and say, okay, so I know what block storage is. And as Isaac said, this is basically the type of storage that is concerned about persisting or storing data in long term at the end of the day. So you're working on some data, you want it to be persistent, you want to be stored, you want to do some additional maybe calculations on that data, you want to do some additional analytics on that data, or you're looking at block storage. At the end of the day, the most confusing part about these types of storage elements is that they are going to have common characteristics, right? For example, you could say that object storage allows you to store large, uh, large, large, large data items. As someone said, you could probably end up storing something like 5 terabytes. But you find that if it's probably not like 5 terabytes in terms of size, you're storing 100 megabyte objects, you find that all these can actually store that type of file as well. So what we are trying to do is get to a point where we say, how do we differentiate? And then how do we differentiate all these and actually come to a point where we can choose to say, this is probably best suited here, and this is probably best suited here. So we start with block storage, and I'll take the diagrams as they are. We have a storage layer somewhere that is, it looks like a bucket, it looks like a bin. We have our storage layer. And usually what block storage is it allows us to say, okay, we have a file. For example, I'll probably want to draw somewhere. So let me just bring this up. Just a quick minute. Yeah. So what we are doing is when it comes to object storage, I forgot that I can share the two together. All right, so when it comes to block storage, we have a file, right? I'll call this file one. And it's a whole file, it's contained, it's everything, it's as it is currently as we see. We have this particular file. Now, what we want to do is probably at some point we realize that we made a mistake maybe with the file name, right? And we want to edit the file and then maybe name it file one, for example. So what happens with block storage is that when this particular file is stored on a block device, and I'll say this is my block device, it's going to be broken down into multiple smaller pieces. And then all these multiple smaller pieces are going to represent this file. So it makes sense to reason that at one point in time, you may be able to work with a few blocks of the file, or you may be able to modify if one block of the file without necessarily accessing the entire file, right? Which gives us advantages in terms of how we can work with files, in terms of speed, in terms of processing, and generally in terms of managing our files and working with them, meaning instant access. We don't really need to do a lot. So it may also stand to reason that if we edit the file name, we don't necessarily need to edit the entire occurrence of this particular file, but we may edit just one block and the rest remains the same, but we still have access to our file, which gives us a lot of speed because now it means we can access the specific block that we need to work with in order to modify or work with that file. So we say that this is basically raw storage, and we say that it's the data is going to be organized as an array of unrelated blocks. So wherever you're editing, it may seem like it's unrelated. Wherever you're editing, you're still working with the same file, but it's behaving as though the blocks are unrelated. But all those different blocks make up the entire file that allows us to access it in different bits and pieces. Think of a movie, you're editing a movie, you're only editing 1 minute of that particular movie. It means you're working with a specific block, not the entire movie, which also does bring us to some other considerations as well. So usually where we see this is in our hard disks, our current laptops, our current machines. This is the implementation that is being used. In our storage area networks, if you're connected to that, in our storage arrays, that is basically what is also going to be used as well, right? So now, we take the same concept and then we move on to file storage, right? So file storage is going to be a bit more involved in terms of how exactly does it handle everything from here, right? So we say that for file storage, it's going to offer the same level of, I want to say, smaller blocks as block storage. But now what it's going to do is it's going to add an extra layer or an additional layer that actually serves as the manager for all your different files, right? That is going to be file storage. And here we're just really trying to build a foundation of how these different models work. And we say file storage, what it will do for you is it will add a management layer that allows, maybe here I am user one. As soon as I get this to behavior, I am user one. And then as soon as I'm done with user one, I can say, okay, now I need to work with Samuel, and then we're working on the same file. Now, what the management layer is going to do is going to track the different changes that Samuel is working on, or user one is working on, and the different changes that Samuel in this particular case is also working on, and say, how do I apply the changes at the block level, right? So that is why Jacob said, this is usually for a multi-user environment or for a shared environment in which our layer allows us to work on the same files or allows us to access the same files in a shared manner, right? So if you're working with block storage, you might find that natively in a multi-user environment, if you're doing that, you might end up overwriting each other's changes. But this particular additional layer gives us access to utilities such as, okay, maybe this file is being worked on by someone else, or these particular blocks are being worked on by someone, and then these particular blocks, on the other hand, they're being worked on by this particular user. As long as the blocks themselves never come into contact to say that, never come into contact in the sense that one person doesn't make changes to the block that you're working on, then it does make sense. But if the blocks are to be overwritten, then it may have some form of way to handle how that is overwritten or what takes precedence, what takes priority. So in that particular aspect, we say that we are taking the blocks that we have and we are going to use a file system manager, or we're going to use a file system that manages our data blocks, right? So we're still using the same disks, but now we have more or less like a manager. So usually these are for shared storage areas like a network attached storage, where you're working over the network, or Windows file servers where you're getting these files from a specific server, and it's probably controlling who gets access to the file at a specific point in time. Right. So as we move forward, we'll also realize that the same can be said for object storage, to say that, yes, we still have the same concepts. I'll take my file and I'll say this is going to be file 1. But in the case of object storage, what is going to happen is that it's no longer going to be treated as blocks, but rather what is going to happen is that my file, there's going to be an additional layer that is going to be added on top of this particular file. And this layer represents the entire immutable object, right? So it adds more or less like a layer, another layer that encapsulates each and every file. So if I were to take these and say, okay, I have this and this particular file, it means, let me just, yeah. It means what I can do is this file will have its own layer. The next file will have its own layer as well. So for each and every file that you put in object storage, there's going to be a layer that is added on top. And yeah, more or less like a virtual container that contains each and every detail about that file, each and every building block about that particular file. It encapsulates all that data, and then it stores object level data about the different attributes. What size is it? What is the name of that file? What type of file, for example, all the different metadata that describe that particular file, and a specific object ID, which usually is the name of that particular file, right? So examples include Ceph, OpenStack, Swift, and we're going to find that in each and every case, we start seeing some advantages and disadvantages, right? So when you're talking about block storage, you're going to find that some of the advantages you're talking about is, yeah, speed. You're talking about easier access, easier modification. We're talking about the ability to basically just work with our files without necessarily accessing the entire thing, right? Now, the next thing that we'll see is when it comes to file storage, there's a bit of a disadvantage in the sense that it means that it's not just about you formatting the hard drive and then it works, or formatting the storage area and then it works. There's an additional layer, which is what manages my files when multiple users are accessing it. How do I get that layer up and running? How do I set it up? Now, for object storage, on the other hand, we're going to see that there's basically no layer that manages everything. It just takes whatever comes in, encapsulates, stores it. Takes whatever comes in, encapsulates, and stores it. So this is also going to lead us to see that in terms of object storage, ease of use, no setup, basically can grow as large as possible. I think someone started describing S3 in a bit more detail. Where we talk about the maximum file size you can have is 5 terabytes in terms of storage. But you're going to find that in terms of block storage, the disadvantage might be the sense that you might not be able to store something that large. And yeah, I think even for much older file system types for block storage, you find that you can even copy an object that is larger than 4 GB. For yeah, those of us who may be a bit older and then we remember F8032, if you had a flash drive with this size, you remember that you couldn't copy anything that was more than 4 gigabytes in as one file. So if you had a Blu-ray movie and you try to copy to this type of storage area, it would actually deny you copying that. So some of those advantages and disadvantages are the trade-offs that we see when it comes to storage. So you as a solutions architect are concerned with basically these storage areas, but when it comes to AWS, we say that our block storage option is going to be in 2 flavors. We have EBS, and one is also the instant store. And then we have file storage, EFS, Amazon Elastic File System, FSX. I don't know what FSX is. Is it file system extended? I'm not sure, but yeah, FSX is also another option, by the way. And then we have S3, Amazon Simple Storage Service. So for file storage, there is another one. It's still a flavor of FSX because it has about 4 different flavors that I can remember. So for FSX, I would present it as one service as an option, but it does also come in the form of FSX for Windows File Server, FSX for Lustre, Lustre, FSX for OnTap, OnTap, and then FSX for should be ZFS. I see a hand. Yes, Isaac.
And I just wanted you to react to a comment in the chat from Jacob.
Yeah, sorry, I can't see. I can't really see the chat. My apologies. I didn't see that.
Yeah. So okay, let me just read it out. So what I was just saying, that means if since files are immutable on A3, if I'm to maybe implement an append, I may have to download the file, modify it locally, and then upload a new version of the file. That's just what I was saying.
I would say yes and no. No about 70%, and then yes about 30% to that. So what happens if I go back to my diagram in Firefox? Remember, we say that for each and every file that you have in S3, it's basically, we haven't really started talking about S3, which I think should be covered later. But yeah, how it works is each and every file that you upload within object storage is going to be managed by an object storage layer, right? So what's going to happen is that if you modify this particular file, it basically creates a new file. It basically creates a new file and adds all the required metadata as well as the layer as well. So it means that you're not accessing parts of the object, but you're rather accessing the entire object. So even if you make a very simple change, and that's why I say yes and no, in the sense that you don't have to work with it offline, but it means that even if you do modify it, you're basically overwriting the entire thing. You're not really overwriting part of it, but you're overwriting the entire thing.
Okay, that's clear. Yeah, okay.
Yeah.
That highlights the difference with block storage. Okay, fine.
Yeah, so basically, when you think about it in that way, and we talk about, we said we have a movie somewhere, and we are trying to modify even just the name of this movie, right? When it comes to block storage, which I'll represent as B, let me also get rid of these. Yeah. So when it comes to block storage, which I'll represent as B, what you're doing is this particular movie is stored somewhere. You have all these different parts that describe the movie. If you're modifying the name of this particular movie, you may just be modifying this part, which can take like maybe 3 seconds, a second, 2 seconds, depending on the speed of your hardware. But when it comes to object storage and you're modifying the same exact movie, what's going to happen is you already have the movie somewhere. It's stored. It has its own layer. Even if you're modifying part of this, basically you're creating a new version of the object and then you're overwriting the entire thing. So in terms of speed, you can see that the considerations for working directly, it's not visibly slower, but the more you work with these different files, the more you need access to these files, the more you're going to find that it presents a bit of an inconvenience to always overwrite the file rather than modify parts of that particular file. Yeah, interesting question. Thank you very much, Jacob. All right. So, as I said, with FSX, you're going to have 3 different flavors. You're going to have you're going to have Windows File Server, FSX for Windows File Server, FSX for Lustre, FSX for OnTap, and FSX for ZFS. Hopefully, I'm getting the last 2 correct, but I know there's OnTap and ZFS. So basically, you have to be able to also differentiate The good thing about the solutions architecting associate level is that it doesn't really require much in terms of the actual details between these, but there are some things that you need to remember when it comes to which one do I choose in a particular situation, which one am I going for in a particular situation. And I know that most of us are already familiar, by the way, with some of these. So if a few people could just volunteer to highlight the differences that they remember, anything. Olu, do I have to call out your name, by the way? I saw that you joined.
Morning, Albert. I mean,
Morning, morning.
differences in what? I'm not getting the question. Sorry.
Between our EFS, native EFS, our FSX for Windows File Server, FSX for Lasta, FSS for ONTAP, and ZFS.
Okay. I think for the for the EFX, how do I put it now? I mean, we already said the EFX is for the file store. I mean, what we use for the file storage, for files, which we do use. Which we know that it's file storage that keeps our data in hierarchy. But for the FSX, we have the four flavors that we've talked about, and we know that the first one, which is the FSS window, it's used to back data for Windows files. The Luster is that, which we are allowed to use. We use that for launching and running high performance Luster files. And then we know that the FX is OpenZX. OpenZFX is used to move the data from AWS online premises to from moving data to online, to online premises, or from online premises, sorry. And then the last one is just used to provide highly reliable, scalable, high performing, and feature rich storage built on that applications, which is the NetApp applications. So I don't know how else to explain that.
Yeah. I think that's very well explained. Thank you very much, Olu. Unless anyone wants to add anything, by the way, but I think Olu, Jacob, please go ahead.
My compliment would just be around that the native Amazon Elastic File System is more for AWS, and the Amazon FX is to cater for maybe customers that are familiar with their on-prem kind of file systems. So they're just trying to support, like, if you have an on-prem file system that you're using, if it is Windows, then to become very easy for you to migrate to the cloud and you use the same file system. I think that's basically how to put it.
All right. Thank you very much, Jacob. I would want to correct you, by the way, just for a bit, to say that EFS. Yeah. So basically, the name of the game when it comes to AWS exams and AWS implementations is basic keywords, right? So I wouldn't say EFS is basically for AWS per se, and then I wouldn't say that the FSX is for on-premises, right? Both of these can actually work either way, either if you're coming from on-premises or you're already in AWS, right? So because where I'm coming from is, I would say EFS, what you're looking for is if you hear about POSIX compliance, right? If you hear someone talking about I want a file system that is POSIX compliant, right? And POSIX compliant usually translates to Linux, right? It means that you're using a workload, a workload that is heavily based or that is consisting of Linux, right? So it means that if you want any file system that is POSIX compliant, whether it's Linux, Unix, it should be Mac OS as well, you are probably looking at EFS. As you said, still it's scalable, still it's highly available, still it provides you all the cool features of it's a multi-user environment. And that also leads me to another keyword to say that if you're looking at file storage, usually the keyword that you're looking for is a multi-user environment or a shared user environment, right? You have developers, they're working on maybe a project and they need access to the same files or they need access to the same files. Someone also explained that you're looking at things like machine learning. When you're doing machine learning, you don't necessarily have your own copy of the data. There's company data, you're working on it as developers, data engineers, you have shared access to the same data. Maybe all you have is maybe a backup and a current copy, but you're not really having your own copy of that data. So in a shared environment, you're working with file storage, right? And if we say this is for single use or personal use, and personal use doesn't necessarily mean one person. It could also mean one application. Your web server, for example, is a single use application where it's saving files, but only that web server needs access to this file. Your database, for example, is a single user. There aren't many databases accessing the same file storage. It's your own one database that is making use of the file system. So single user, block storage, multi-user, file storage. Differences in file storage themselves are going to be EFS POSIX compliant, meaning that you're looking at a workload that usually the question will hint and say that it's a Linux-based workload. It needs shared user access. And then you're going to know that, okay, this is EFS, native EFS. Now, the difference is not everyone uses Linux as their backend, right? Some people use Windows, like it's dominantly Windows, 99 or 90% Windows. For some reason, by the way, I'm very biased towards Linux. But yeah, for some reason, your entire corporation is using Windows. It means that Windows isn't POSIX compliant. EFS won't work in that particular instance. And what you're going to be looking at is FSX. And because FSX has a flavor that is known as Windows File, FSX for Windows File Server. And what this is going to hint to you is that it's usually a Windows-based environment, right? It's going to tell you that probably they want to make use of native Windows features or Windows Server features, such as Active Directory, domain joins, domain authentication and authorization. Maybe they're building a forest. At the end of the day, it's going to hint using one of those Active Directory, native Windows features, a Windows-based environment. It means you're looking at FSX for Windows File Server, right? Now, the other three flavors, I think at this level, ONTAP and ZFS won't really be tackled in as much detail. But Olu brought up an interesting keyword when it comes to Lustre. Lustre is for high performance computing clusters. So if the question now doesn't necessarily specify Windows, Linux, POSIX, but Lustre should also be uh, geared towards Linux. I think there's an expansion for Lustre that I'm forgetting, but yeah, usually Lustre will hint towards high performance computing. It will tell you that it needs to make use of like super super fast storage, and that is what the Lustre file system is. It gives you access to like really low latency storage. It creates the file system in a way that when you're accessing the files, they are accessed as quickly as possible, meaning it's going to be much high performance than EFS. And you're going to be looking at this when you're looking at maybe file storage clusters. You need access to really low latency storage of your files. But most of the time, the keyword for this is going to be high performance computing, right? Now, for ZFS and ONTAP, if you hear that someone is already using, because for some people they're not using Linux, they might be using Linux, but they're not using a native Linux file manager, right? They may be using something like OpenZFS or NetApp ONTAP. So if you hear that someone is migrating and they're already using NetApp on tap, or they're already using OpenZFS, then they can make use of FSX for on tap or FS for ZFS. Usually the question will hint to say that this person or these people are already using this particular type of file storage. Even you as an architect in real life, someone tells you, I'm already using OpenZFS. You don't migrate them to EFS. You migrate them to FSX for ZFS, because there are particular features about ZFS and ONTAP that work differently from how EFS works. So some people may want to make use of that native functionality. And yeah, as you say, Jacob, there's native functionality like for Windows Active Domain. Same thing with the likes of ZFS and ONTAP in how they present the clusters of data, how they present your data, and basically how you access your data. Things like caching, for example, things like primary storage for something like ONTAP. Those are some of the features that someone may be looking for. And at this point in time, I realize that I've said quite a lot, and I would want to take questions just so that it's clear in our heads. Like, when we come back and we are doing practice exams, by the way, Pauline, do remind me when you're asking about EFS and FSX and all its flavors. If someone gets something wrong, do remind us that we had this moment to ask, so that it just settles, and then no one is ever confused about these ever again. So I'll take questions, unless it's clear. Okay, there are no questions, but there are no thumbs up to also indicate that it's clear. So we are in warm, hot water. All right, I see a thumbs up from Jacob, Olu. Thank you. Okay, I see one from someone as well. So 3. Okay. Yeah, but just build a mental model that makes a bit more sense. EFS, POSIX, Linux workloads most of the time. FSX for Windows File Server, native Windows features, Windows Active Directory, domain joins, high performance computing cluster file system, Lasta. Open ZFS on premises is ZFS, FSX for ZFS, using on NetApp on tap, FSX for on tap, or yeah, NetApp. And then we move on to our last bit, which is object storage. Now, object storage, most of us are familiar with from Cloud Practitioner Fundamentals, which is basically that in AWS, the storage service that is responsible for object storage is S3. And the service that is responsible for archiving and backup is also S3 Glacier, which makes use of object storage, which is great for backup and archives, because when you take an entire archive, it makes sense that you'd want to store it as one object. If I say I have an archive for yesterday, or maybe I have two archives for yesterday, I would want both of them to be completely different as objects, rather than making changes to part of the archive so that I have two different copies of the archive. So the beauty of object storage is also in the fact that there isn't much to consider. Same as we start seeing that with file storage, it may not be as straightforward. Block storage is the same, but because usually it's handled by our compute layer, how the interaction goes between block storage and our compute layer, it seems a bit more straightforward. But file storage, there are a few more considerations. Object storage, the advantage being that we don't really have to make most of those considerations. Whatever we throw in there, it's the responsibility of S3 to add a layer and then store it as it sees fit. There is no, everything is stored as, it's a flat storage area. There's no concept of folders or files. Everything is in just one area with that particular container. So even if I know in S3 we are able to create files and folders, but yeah, to the eyes of S3, these all look like the same thing. Folders just look like prefixes, or what you attach before the name of a file in order to get to that particular file. So it's a flat file system. So it makes it quite easy for you to just say, I don't want any considerations about what file storage type I'm using. I don't want any considerations about ABC. All I want is a storage area, and I want to throw my stuff in there. So that's object storage, which will be covered in its own in its own course, because it's quite a huge topic as for a solutions architect S3. But for the meantime, we should remember that the service that is responsible for object storage in AWS is S3. The service that is responsible for archival storage but still uses an object storage mechanism is S3 Glacier. Right. I don't think I'm seeing any questions, meaning we should be okay. So we'll move on to the next part, which basically is what constitutes storage areas for our EC2 instances. Right, so we start from the top again. Amazon Elastic Block Store, right? There are a few keywords that are going to be common, as I said, across Elastic Block Store. They're going to be common across EFS, FSX. By the way, you're going to cover EFS and FSX, I think, in the next part of this. So don't worry about it. But yeah, on the other hand, we start with Elastic Block Store, and we really just want to understand what it is, how it works. And we say that one, it's going to be a scalable storage layer that is attached to your compute layer, right? And it's also going to be high performance. There are a few ways you can actually tweak that. But at the end of the day, it's a resource as with anything else in AWS, your EC2 instances, but we treat storage as a resource. I know we see it, but it can be treated as its own resource, and depending on on how you use it, it can be quite a critical layer. So it can be used with different compute units, one of the most common ones being an EC2 instance. And what you can do is you can create volumes, which are basically your storage areas. You take a look at your machine currently, your computer, you have an SSD, a hard drive, that is going to be your volume, right? And what you do is you attach this particular volume to your compute layer, an EC2 instance, and you can then use this EC2 instance as though you have a local hard drive attached. The beauty of getting hard drives is that you're not limited in terms of how much in terms of size. What limits you is basically the cost, and those are some of the considerations that you make when you're an architect as well. So you have a hard drive, you can use it to store files, you can use it to install applications, you can use it to analyze data, you can use it to run databases, simulations, anything you need. As long as you have an EBS volume attached, you are free to go as crazy as you need. So you are also allowed to create snapshots. As I said, this can be quite powerful in the sense that you have the ability in the cloud. Yes, you can get a hard drive on premises, but you have the ability now in the cloud to say that I have a copy of everything that is on my hard drive, such that if I were to lose my hard drive, I could basically create a new hard drive, and it would contain a copy of the data of everything from my hard drive, right? Without having the actual hard drive. So these snapshots are basically a point in time backup of your volumes. And the beauty is that they are independent from that volume itself, right? So you can create snapshots anytime you need manually, or you can create automated snapshots with EBS. And that's the flexibility of the cloud to say that if I need to create snapshots at a specific point in time, I can use EBS snapshots. And then you can use the same snapshots to restore or create a new volume that contain the same type of data as your EBS volumes. So it means that in this particular case, we can have an EC2 instance. From this EC2 instance, we install everything we need, and then we store a copy of this installation and say anytime we need to create an EC2 instance with this configuration, we can mount or restore from the snapshot that is a copy of everything that has been installed. Imagine maybe you have your application set up from GitHub, you have your Apache web server, your MySQL database, and you need that data to persist across EC2 instances. It means that it now provides that particular mechanism. And the beauty is that all these exist independently of the EC2 instance. They are treated as their own resources. Right. So when we move from the point that EBS is durable and EBS is also detachable, and remember it's block level storage, it means that we can even have an EC2 instance running, and instead of creating or going through the process of, okay, I have my instance and I'm going to create a snapshot, and then from the snapshot, I'm going to create another instance. We can move from this architecture to directly saying, okay, I have another instance, it's already running. I'm not going to create a snapshot, but I'm going to take whatever EBS has been attached to this instance, and I'm going to attach it to this instance, and it would have the same exact data, right? So they are usually mounted to the instance itself, and it means that because of that particular mounting, there is a bit of a network delay, but it means that you have very low latency. You can hardly feel the difference. Yeah, unless someone can say that when I was working with the EC2 instance, I thought it was too slow, or I felt like when I was accessing the files, it felt too slow. But I think we can all testament to the fact that when you're using SSH, whatever you're using, remote desktop, when you're working with an EC2 instance, it always feels like it's instantaneous, even though it's attached, right? So there's hardly any latency between where you're getting your data and where you might need to use it on your instance. So you might find an EC2 instance, an EBS, or yeah, an EBS volume makes quite a lot of sense in different applications such as databases, where you might feel this latency if you're using something like a database, if there was any latency. Yeah, so where your EBS snapshots are stored is within Amazon S3 as your backend. As I say, they live independently of your EBS volumes. If your EBS volumes for some reason get corrupted, your instances get corrupted, your region gets lost, as long as you have that copy in Amazon S3, you are able to recreate, reuse, and actually rebuild from the same snapshot. So you can store all the data that you need for your EC2 instances into your snapshots and then restore them later. So, yeah, when it comes to EBS, we get a number of features. One, you have the variety in terms of what do I need as my, yeah. You have the choice in terms of what do I need as my EBS backend, right? Uh, Same way that we have on premises, you can choose to buy a hard drive because it may be a lot cheaper, or you may get much in terms of size versus the cost. Or you can buy an SSD, or you can buy something even faster. I'm not sure in that particular sense, but you have the same types of options where you have multiple volume types. You are allowed to optimize the storage performance and the cost for a number of different applications. So these are divided into two major categories that we'll see. Usually we'll have SSDs, and then we'll have HDDs as well, hard drives or solid state drives. If you have something that is a bit more throughput intensive, for example, you might be looking at hard drives. If you're looking at a lot of sequential read and writes, but if you're looking at something that is a bit more I/O heavy, then you might be looking at SSDs. And we also have scalability. With an EBS volume, you don't really consider to say, I need 20 gigabytes and my application is going to use 20 gigabytes. It's very scalable in the sense that you can attach it to an EC2 instance, and later on, if it needs to grow, you can actually keep growing it. So you can tune it on the fly as an instance is running, to basically maybe move from 20 gigabytes to about 100 gigabytes. The catch being, most of the time you can only move up, you can't really move down. So if you move an EBS volume to 100 GB from maybe 20, and you realize that you only needed 50, you might not be able to go back to 50 unless you go back and create that one process that we described, where you create a snapshot, create another EBS volume that is 50 gigabytes in size, and then you restore the snapshot from that. But yeah, most of the time, the beauty being, if you need to scale up, it can scale up as much as you need. up to a maximum of 16 terabytes. Yeah. So do also be aware of that limit. So if you ever see a workload that requires more than 16 terabytes, I would not recommend attaching multiple EBS volumes to segment, but I would recommend looking into a different storage service or a different, and maybe a file system, for example, file storage service or object storage. You also have backup and recovery, which I think I backed it up and recovered because I see it twice. So you can use snapshots to actually back up all your data, and then all the data that is stored on your volume, you create it as a snapshot. You store this snapshot in S3. And from S3, you have a range of different options rather than just recovery. You can copy to different accounts. You can share the data. You can restore whenever you lose your data. You can move this data across availability zones. You can move this data across regions as well. You have quite a number of flexible items. So trying, if you're ever trying to create a backup, most of the time know that EBS will live within an availability zone. Not most of the time, but it lives within an availability zone. So it means that if you need to move your EBS volume to maybe availability zone 2, you need to first create a snapshot and then recover from that snapshot in S3 from the other availability zone. So it doesn't move directly, but you need to create a snapshot first. So that backup and recovery process makes it quite durable. So data protection, which is also common across most of the storage services, is basically the fact that you also have encryption, which is TLS encryption at rest. So all the data that you're storing can be encrypted in your EBS volumes and EBS snapshots. You can even incorporate this with KMS or key management service to say that I want a different encryption key. But it does also mean that if your data is encrypted, if you're creating snapshots, you also need to share that encryption key, or the person who's going to be decrypting the data needs access to that decryption key, right? So you can, you can encrypt your data. It doesn't really have much of a performance impact, but it's a matter of ensuring that you have security at rest. And when you're transferring the data, maybe in between instances, you know that when it gets to the instance, it's going to be encrypted. And the snapshot as well can also be encrypted. So you have all those options to say that it's not just a matter of the EBS itself, but what EBS can create can also be encrypted, or you can choose to not encrypt the snapshot so that it's a bit more open, but I would suggest you encrypt. Yes, Jacob.
Yeah, so there is a question on the chat from Hassan. He's asking that the scalability you're talking about, does it happen automatically or you need to scale manually?
So yeah, Samuel, thank you for the question. So it happens manually. That needs to be done manually, by the way. So because yeah, I know I said this, but you don't really have to think about how much storage you need when it comes to an EBS volume, right? But how much you allocate is what you're given, right? It doesn't automatically grow. So it means that if you ever need to increase it, it's based on your judgment, right? It's not based on your use, but it's based on your judgment. There are a few cases where you're going to find that an EC2 instance runs out of storage. You can simply increase it. It's like one or two steps, by the way. It's like you need to go there, you specify how much you need, you see the size. Maybe it's 30 GB, you need to go to 40 GB, specify the new size, and then all of a sudden it's added to your EBS volume. There are a few considerations, by the way, where I think it takes a bit of time for it to reflect immediately once you do that, right? But if you want to expedite it, you can simply restart your instance and then it shows up immediately that it's now extended. And yeah, it works perfectly. At least for me, 100% of the time it's worked. But yeah, you need to do that manually just to answer your question, by the way. So you also have that data availability and durability that AWS always offers. So you're going to see a variance of EBS called IO2 Block Express and SSDs. but the one that offers the least amount of durability is around 99.8, which is still really high. An annual failure rate of 0.1 and 0.2. I think if it's calculated, it means that over the year, it should be around 50 minutes or so if it's 0.1. So yeah, 50 minutes spread across the year, I think it should serve most use cases quite perfectly. Yeah, so the good thing in terms of durability is that um, the data within your volume is replicated across multiple servers. So if a server does fail and your volume was on that server, it doesn't mean that you lose your data. And that's why you find that most of the time EBS hardly loses data because it's going to replicate it across multiple servers within the availability zone, right? So that also does contribute to its durability. So when it comes to archiving, snapshots, very powerful in terms of if I want a data archive of my EBS, it's low cost because it's going to be stored in object storage. It's a full copy of everything on that EBS volume. It's a point in time recovery. So you can say that at this specific point in time, maybe last week on Wednesday, depending on the frequency of your snapshots. And you can also have another setting where all your archives should be stored for at least 90 or more days if there is a regulatory requirement or a compliance requirement that you need, or maybe for future project releases. So you're going to find that EBS is quite compelling in how it handles your different storage needs. Now, as we said, EBS is a service on its own. It's independent from instances. So you find that your host or your instance is going to be stored on a different server. From that particular server, you're going to provision an EBS volume, right? So this EBS volume is going to be attached to the instance, meaning that if this server, for the instance, it can fail or it might fail, but your EBS volumes may still be protected. And as I said, these are also going to be duplicated across multiple other servers. So even if this one fails, your instance still has access to that one server that has replicated data. So there's a lot of magic in the background. But yeah, at the end of the day, it also does mean that because instances live independently, you're not just limited to attaching one hard drive to your laptop. You have multiple ports. Same thing happens for instances. You can have multiple EBS volumes attached. You could have a primary EBS volume and a secondary EBS volume up to 4, 5, 6. I think there should be a limit that I'm not super sure of currently, of how many instances you can how many EBS volumes you can attach to an instance. But it should be quite a few, right? And remember, these can scale up to 16 terabytes. So you have a lot in terms of flexibility of the size. And because of this particular setup, it allows that durability, that availability where this storage layer can then scale independently of the compute layer. One consideration you should be aware of is the fact that for the primary instance, it may not be as flexible as the secondary instance to attach and detach, but you do have that feature in EBS. So for EBS, you can take a snapshot of the primary EBS volume, but you can't really detach it from the instance, especially if it's running. You might need to do something like maybe you terminate the instance, you protect the EBS, and then you attach it to a new instance. But it's not as straightforward as if you have a secondary EBS volume. For this one, you can detach it instantly and then attach it to another one. Maybe you even attach this one just to copy data from the primary one, and then you then attach it to a different EC2 instance. Right, so if there are no questions, I'll step into, yeah, Samuel Olu says up to 128 volumes to an instance, which is quite a lot. Someone is asking, another question is that, do we get notified when we are nearing the 16 terabyte limit or other to upscale? No, and yes, no, around 80%, and then yes, around 20%. Because no, excuse me, no, you don't really get notified when you're reaching your limit. You don't get notified automatically, right? That's what I'm saying. No. But yes, in the sense that you can set up a CloudWatch alarm, monitor a specific CloudWatch metric, which in this case is disk I/O usage. It does have that native feature to monitor EBS volumes, right? Remember, monitoring is common across all these different store, actually across every AWS service. So you can set up a CloudWatch alarm, and then you can trigger maybe an SNS topic to send you something like an email once you are reaching a particular point of usage. Same thing with CPU utilization. If it reaches 80%, you can choose to auto scale or you can choose to send an SNS alert. So that's basically the setup even with EBS, where you say keep monitoring how much I'm using. If I reach maybe 80% of the total disk size, then notify me. If I reach 90, 70, 50, you can be notified via SNS and CloudWatch alarms and metrics. So hopefully that makes sense. Yeah. All right. So because I do remember there's some cases where you're working with an EC2 instance, you're trying to install something. I think lately I was trying to install Superbase on one of our instances, and then I was basically testing, right? So I didn't modify the defaults. Which is basically 8 GB, and Superbase would probably require around 5 GB if I'm correct. And then for your operating system as well, it's around 2, 3-ish, if not 4. So meaning if you provision 8 GB and then you try to run that entire process, you run out of storage. So I just remember seeing the error that I have run out of storage, and the command for installing Superbase couldn't complete because the storage ran out of storage space. And that is where I remember that EBS can be automatically adjusted. And I went back, modified the size, I think to 20 GB, reran the command, restarted the instance, reran the command, and everything was then working. So it makes quite a bit of sense in how it works. So you're not notified when it's getting full, you're not notified when you run out of storage. You just realize that maybe some things stop working. Yeah. For example, with CPU, you might find that your server just starts slowing down. Right. So we move on to the volume types in the absence of further questions. In the sense that now we have different options. Yes, SSDs, and we also said we have HDDs or hard drives. But what exactly do they offer? And we say one, we have general purpose. So general purpose is going to be what I'm doing is okay. It doesn't really require any high performance, low latency. It's not sensitive to any. It's not really sensitive to any changes in the performance of the storage. Um, Maybe you're running a very basic web server. You're serving 1,000 people, maybe 10,000 people. Most of the time you're going to find that that storage doesn't necessarily need to be tweaked in order for it to work. It works great out of the box. So for most use cases, a database, a general storage area, a user is logging onto an EC2 instance, find that general purpose is very good. It's cost effective and it comes in two different flavors. Basically one flavor, but two different generations, GP2 and GP3, which aren't really that different. But both of these are solid state based and they are quite performant. Um, so if you want a boot volume, for example, a small to medium database, I could even say a relatively large database, depending on its use case, and your development and test environments, even some production environments, I won't lie, they run on general purpose and they don't really suffer any performance impact. Now, if you get to a point where you say, okay, now I am suffering the performance impact that you said, and I have duly noted that this is because of my storage layer. I have seen that my CPU is okay, my memory is okay, and my latency is coming from the storage layer because it's not fast enough, doesn't provide enough IO throughput. Then you can look at the provisioned EBS volumes. So these are usually focused on providing more IO, right? So they come in in two flavors, IO1 and IO2 Block Express. And these really are just when you have any IO intensive workload. There's a lot of reading, writing. We're talking about maybe machine learning. We're talking about complex analytics. Maybe we're talking about high performance computing at the end of the day. Yeah, or a very large database that really needs the storage performance to be consistent, because sometimes general purpose it can be high, sometimes low, but if you need a lot of consistency, then you can go for provisioned IOPS, right? So they give you a constant IOPS rate, right? I usually like to ask the difference between IOPS. I hope you ask yourself as I'm asking if you understand the difference between IOPS, input output operations, versus throughput, by the way. So IOPS, excuse me, IOPS basically are how much you're reading and writing to that disk. You're making a lot of changes to your data. And at some point, there's going to be a point where your storage layer might not be able to handle the number of requests that you're making for the changes to the files in terms of reading and writing. That's IOPS for you. So you can specify the IOPS rate after you have measured, because when you get to this point, you also understand how much you actually need in terms of IOPS. After you have measured, then you can specify the constant rate that you need for the performance of your EBS volume. So it's going to deliver that performance or the volume. For example, these may not be real numbers, by the way. You may say that maybe for GP, it may range from maybe, let me say 100 to maybe 900 IOPS, input output operations per second. But this range means that at some point in time, it can be 200, at some point, it can be 300, up to 900, right? Which may not be what you need if your application is very sensitive. Now, for provisioned, you say that I need this to consistently perform maybe at 2000 IOPS, and then all the time, your EBS volume will try to function at 2000 IOPS 99% of the time. On the other hand, we have HDDs, which I would want to say the hack for this one. ST is focused on throughput. By the way, that's why I say you need to also build a mental model of what's the difference between throughput and IOPS. And yeah, as I said, IOPS, output operations per second. How much are you reading and writing to that disk? Throughput, how much are you reading sequentially, right? In terms of chunks, how much are you reading from your volumes? And this may also be a difference. If you need to read maybe many 5 GB files many times over and over, you might find that your throughput might not be what is needed. But if you need to write number of files, many files, even smaller files, really fast, you might find that you're looking at IOPS. So build that mental model. But the hack is for ST1, SC1. I usually see the T as throughput and then the C as code. So throughput for this one means that it's going to focus on a lot of throughput rather than IOPS, allowing you to work where you have a large sequential workload, such as EMR, Elastic MapReduce, or you're working with ETL such as Glue, data warehousing, where you have maybe large archives, log processing. This may be a good fit because now you're reading a lot of data in one go, right? So that's going to be the ST1 or HDD ST1. For HDD SC1 or cold HDD, this is going to be in terms of, yeah, it's still going to focus on throughput, but it's going to be really cheap, and especially for data that is infrequently used, right? So it's inexpensive if you rarely access the data, but if you need to access that data um, in the same sense that you would EMR, but less frequently, maybe, yeah, these are your logs, these are your archives. Same thing applies. This is your storage area for where you're dumping. We need this data, but we don't know when. Maybe once in 3 years, once in 2 years, it's going to be low cost, but really good when you need to access all that data at once, which is the sequential part. So the differences are very minimal. But for your SSDs, this is for high performance. Usually your GP general purpose SSDs will do well in most cases. But if you need consistent performance, you cut the line, you go for either IO1 or IO2 block express. Same thing, if you want something a bit more throughput optimized, you're looking at HDD or SC1 if this is infrequent access data. But you still need that performance on your end. Okay, so if you take a quick look at, let me get my, see if I open this. Yeah. Go back to my, yeah. So if I would usually want to get the latest information for this, which basically means in terms of comparison, they differ, yes. You're not really going to probably make the comparison in the exam, but just to make a bit more sense out of it, I think it works the following way. In terms of durability, as I said, the lowest one offers 99.8, which is 0.2 annual rate failure. Change the color for that. Yeah, 0.2 in terms of annual rate failure. That's for GP3 and GP2 and use cases, transactional workloads, virtual desktops, this work, medium size, single instance databases, low latency interactive applications, boot volumes, development and test environments, and the maximum size, 1 GB minimum, 16 terabytes, which which is a good size. In terms of input output operations, these go from 16 these go up to 16,000 in terms of IOPS. And then you're also going to find that for the throughput, GP3 is going to have higher throughput, and then GP2 is going to have lower throughput. So there's a feature of EBS called EBS multi-attach, but meaning that you can have one EBS volume and then attach it to multiple EC2 instances. The maximum that you can attach is up to 16 EC2 instances with one EBS volume. There should be an EBS type that supports EBS multi-attach, but it's usually for Nitro-based hardware. So it doesn't work on all EBS volumes like GP2, GP3, even for IO2 Block Express, IO1. So it might not be, even if you see it as opposed to file, the file storage, you might not really want to use this. For the rest, quick comparison, throughput maximum for IO2 Block Express. You don't have to know these by heart, by the way, just to see that in terms of performance, these will usually perform much higher. IO1 isn't as different from the GP2, GP3. Except the fact that it has a lot of input-output operations. But in terms of throughput, these don't differ much, but IO2 Block Express is probably the most high-performant one, which can go up to 4,000 megabytes per second in terms of throughput. And then it can also go up to 256,000 in terms of input-output operations. So this is relatively a large difference. Even from 16 maximum to 64, IO1 might be a good option. And in terms of size, I think this one also does prove that it's high performance. It's the only one that can go up to 64 terabytes. So for this one, you're really looking at workloads that require sub-millisecond latency, a lot of sustained IOPS performance, and then, really just a lot of throughput and IOPS. This may be applicable where you're looking for something just larger than 16,000. But if you're looking for anything larger than 64,000, then you're looking at IO2 Block Express. Still, same thing applies, IO intensive workloads as well. So for that, we'll move on, and then we'll also do a quick comparison of the throughput optimized HDDs. Yes, Jacob.
Yeah, just written a question around. I've observed that AWS uses some units, TIB, like terabytes. I don't know why. Maybe the use case is they add the I instead of just the normal measurements that we use, say terabytes, gigabytes, megabytes, but they have the I. I don't know why. Or what's the use case for that?
All right. I have never really looked into the actual units as to why they add the I. But yeah, I think from my knowledge, by the way, which is not an expert opinion, I usually look at these the very first one and the very last one, which in some cases, if it's a small case, if it's a small letter B, it may mean bits rather than bytes. So that's usually what I look at. If it's a larger case B, it's usually bytes rather than bits, which the difference is about 8 in terms of single bits. But for the I itself, I don't think I've ever really looked into if it makes a difference in terms of storage. But if anyone knows on the call, then I think you are welcome to assist us. Yeah, interesting question. Kevin, I thought you were explaining.
So based on Google, I see TB is for terabyte and TIB is for tebibyte.
Ah, okay.
And tebibyte being a binary of base 2 and terabyte being a decimal base 10.
Yeah, that makes it a bit more confusing, by the way. What
Yes, I
about
think
GIB?
so probably then it will be JB bytes or something of sorts.
Okay. I might need to revisit my storage units, but yeah, I'll probably have an answer in the near future. Thank you very much, Kevin. Thank you for the question, Jacob. Okay, so quick comparison for the volume types. ST1, SC1, same thing applies. Very high durability and availability. This is throughput. You're looking at big data, data warehousing, log processing, basically just anything, ETL, anything to do with large chunks of data. Same thing applies, but this is for SC, but this is for infrequently accessed data. And you see that maximum volume size is the exact same as the SSD based ones, except IO2 Block Express. In terms of IOPS, it's much lower, but is it significantly lower to warrant the cost? But in terms of throughput, this may be as if not higher. So yeah, that is basically that in terms of that quick comparison, and we will go back to our slide, and then we'll finish up with the instance store. Pauline says GB, MB, TB are part of the decimal system, powers of 10, right? 1 GB is equal to 1 billion bytes, 10 to the power 9. 1 terabyte is 10 to the power 12. Whereas GIB are part of the binary system, powers of 2, where 1 GIB is 102 to the power 30, and then 1 TIB is 2 to the power 40. Does that give us more storage, by the way? I think it gives us more storage, but yeah, we need a storage engineer at this point. But yeah, thank you very much, Pauline. I think to some extent it makes sense. Yes, Major. Now, if you're speaking, you're muted, by the way.
Hello, Banda. Morning.
Yes, good morning.
Sorry, I was talking and I was muted, actually. So I was telling that for me, the reason I understand this JB byte and GB, or maybe megabyte and B is that, when you have your flash disk of 4 GB, it's normally not 4 GB, it's around 3.7.
Yeah.
So this GIB solves that thing. You can see it's more than. So if it tell you that it's 4 terabyte, it will be 4 terabytes because of the number system, the power 2. So
Yeah.
I think that's why they try to give their customer the exact storage size so that know that your provision are 10 terabyte, but you are getting like 9 point something terabyte. So the GIB, MIB, and TIB solve that problem. That will get the exact volume that you have requested.
Okay. I think that makes a lot more sense. Thank you very much, Major. Okay. All right, so we finish up with EC2 instance stores. So different from EBS volumes. Remember, we're still all treating block volume, block storage. Sorry, Pauline, yes.
I just wanted to tell you have like 9 minutes.
Yeah, my timer says 9 minutes and 30 seconds, so don't worry. All right, thank you for the reminder, Pauline. So an instance store provides temporary block storage. It's a bit different from it's a bit different from EBS in the sense that most of the time, when you're creating, remember we have this particular diagram and we say this is our instance. When you're creating this particular instance on the server, on the host where it lives, there is a bit of storage that it can actually utilize, right? So this lives together with that particular instance storage. It's physically attached. You don't need to attach it like an EBS volume, different server attached. But with this one, it's physically there, physically connected. So what this brings in is the sense that it's going to be good if you're storing temporarily because it's not going to be replicated across multiple servers. But basically, if that particular server does go down, everything also does go down. So it's good for temporary storage or storage that changes frequently. And in terms of performance, to be honest, not every instance supports instance stores, but they are the highest performance storage areas because there's no attachment, it's physically there, and most of the time they perform even higher than the IO2 Block Express, but it's not recommended to use because if the instance does go down, it means you're losing all your data. So usually for temporary data, such as maybe a buffer, you're processing somewhere, you're using that instance store as a buffer. And then as you're processing, you're working with that instance store, but your output is being stored somewhere. That's going to be good. Your cache, you basically have a data store somewhere. You're only storing the most frequently used data of the instance store. And then, but you know that that data is being fed from somewhere. You can't lose it. Or even if the instance store does go down, you won't lose it. That's going to be also really good. Any scratch data as well. Any other temporary content, by the way, it's also really good. But at the end of the day, just know that whatever you do put on that particular instance store, if the instance itself goes down, it goes down with the instance store. So if you're running a database, it means that whatever you had on that database goes with the instance store. So one is going to be directly attached to the EC2 instance, and not every instance supports it, by the way. Most of the time when you're creating an EC2 instance, you're going to find that by default, it's going to go with EBS. It's very low latency. As I said, it outperforms most of the EBS volumes, high IOPS, high throughput, but it's temporary. And if you do also terminate the instance, it's not always the case where the server experiences some form of error. But if you do terminate that particular instance, you end up destroying or you end up saying, I'm stopping my instance, then it means that you might also lose the instance store. And it's also available in all the different flavors, NVMe, SSD, and HDD as well. But the thing is, because with AWS, you have an instance, you have multiple servers. If you terminate this, the probability that your instance is going to be created on the same exact server, the same exact rack, is usually very low. So that's why you find that it's also terminated with your instance as well. So yeah, use cases, most of the time, buffers, cache, temporary data, anything you can think of that I can easily recreate, easily replicate. I'm not losing it. not necessarily having any issues. If it does go down with my instance, then your instance store is going to work for that as well. Yeah, so basically with instance store volumes connected, if it's running, you have the access to everything. If it stops, you lose both of these. But because it's available in NVMe SSD, it can be quite fast. Yeah, so with that said, I think I would want to take any questions, any contributions at this point before I hand over to our moderator to take over at this point.
Would it be correct if I say that this is equivalent to RAM on my normal storage, on my normal laptop, let's say?
No, I think the analogy would usually go along the lines of um it's your internal hard drive rather than your external hard drive, with EBS being your external hard drive. There's a bit of a mess in between, but I think it makes a bit more sense to say that if you lose your laptop, you're not losing your external hard drive, which is the EBS part. But if you lose your laptop, you're losing your internal hard drive as well, which is mounted to the PC, right? So you also do have memory as well, which is going to also be quantities higher in terms of performance. Yeah, because memory itself as well, it's also going to be available besides the instant store volume. It's just that I think they're going to go, what do you call this, band for band in terms of storage, because it's high performance storage. All right. So I think you are welcome, Jacob. Thank you very much for having me. Otherwise, I think I'll hand over to my moderator who complained about time. I still have 3 minutes and 23 seconds. But yeah, Pauline, over to you. Thank you very much for having me, everyone.
Yeah, I have to complain. Okay. So Isaac, I think we can take like a break, 10 minutes, and then we'll start at 11:40 EAT. So Anthony will take over from there.
All right. Thank you so much, Albert. It's been a powerful engagement session. So yes, as Pauline has said, let's have that break and then I reconvene at 11:40.
Yeah, our time is up, Pauline. 2 minutes earlier than you specified, but time is up.
It's okay. Thank you so much, Albert. Hello, Anthony. Okay. So
Hello, Pauline. How are you doing?
I'm fine. I was
Yes.
about to find you behind the tents.
Sorry. I was just preparing myself here, but I am around. So
It's okay. So you can take over whenever you're ready.
okay. Thank you so much, guys, for inviting me over. My name is Anthony Nzuki. I have interacted with I think two of you. I think Pauline, we have interacted with you before. I've also interacted with Olu before. I don't know if there are others who we've interacted with before from the chat, but glad to have you all on board. So I am an AWS Restart instructor with the AWS Restart program, and I'll be presenting on Amazon EFS and also Amazon FSX. And good job from Albert. I think you've summarized everything, Albert. I am even wondering, what do I do in this class? When you started off, I think you talked about EFS, but I think it will be justifiable enough if we did a demo just to showcase what Albert did. So allow me to share my screen in a second, then we can move. Okay, so we are going to look at this documentation just to look at what EFS entails, and then from there we can go ahead and do the demo. So if you have any question, please do not hesitate from muting. I might not probably see your hand. So Amazon EFS is the Elastic File System Service, and it's basically just a shared file system where if you need a number of EC2 instances to probably share a file or share a directory within your Amazon EC2 instances, then you definitely use a service like Amazon EFS. So as we start off, we are just going to look at just an example of two EC2 instances that we are going to create, and then see how we are able to mount the EFS file system onto our EC2 instances, and then we'll just compare and see if the two instances are going to indeed connect to the same EFS file system. So ideally, that's what EFS is all about. So it's a fully scalable, it's a scalable, fully managed Elastic network file system storage for use with AWS cloud services and on-prem resources. And the reason why we are saying it's fully managed is because when it comes to aspects like storage is basically scaled, because you'll realize that as we do the demo, you'll realize that the storage starts off from 16 kilobytes as we move. So the more the data that you ingest into your EFS file system, the more storage is actually going to be increasing as you move. And therefore, we might term it as fully managed because you don't get to interact, or you don't get to specify the amount of storage that you will need for your Elastic file system. Same goes for encryption. AWS will provide like a host of tools or helper tools that are going to help you in configuring the NFS client, configuring TLS in terms of encryption, performing retries whenever there are problems with mounting, and all that is managed. And therefore, that's why we would indeed term EFS as a fully managed service. So as you look at the features, first things first, I think we said that an EFS is POXIS compliant, meaning that it's compatible with all Linux-based instances and servers. Two, we are going to specifically use NFS version 4, meaning that it supports NFS. We can always integrate it with multiple AWS services, and definitely you can always use tags to uniquely identify your file systems if you have more than one EFS file system. And some of the benefits, just like they were highlighted before, we benefit from high availability because as you're setting up your file system, you're able to mount the EFS file system onto the different availability zones that exist within a specific region. So if you want it to spread across 5 availability zones, then EFS will definitely assist you in that. We've talked about storage. It starts off with 16 kilobytes. You might think that it's got very low storage, but it will definitely scale as you move. So you're able to grow and shrink storage automatically as you add or remove files. Then we've also talked about it being fully managed, meaning that it's able to provide a shared file system storage for Linux workloads. So EFS is purely for Linux. So as you approach the certification and you've seen something like POXIS compliant or a shared file system that is compatible with the Linux operating system, always go for Amazon EFS. Then in terms of performance attributes, I think I won't belabor so much on this because you're also going to look at it in the demo. We are saying that there are different storage classes that you can have for your EFS file system. That is EFS standard storage, and we have one-zone storage classes. So the default one mostly will be the standard storage class, where we have the EFS standard and the EFS standard IA. I think these are things we've taken from Amazon S3 in terms of stating that we have an EFS standard, which will be for your most frequent workloads that you are interacting with on a day-to-day basis. And if you have infrequent access, then you will find that you're able to even create a lifecycle policy where EFS will intelligently tier your data into different classes, be it standard and infrequent access. So you were able to transition data from standard to infrequent access by the use of a policy that you're going to set up. And this policy will definitely intelligently tier your data, probably after 30 days to move into infrequent access and such. And we have the other storage class, which is one-zone class, storage class. Now, before I get to one-zone, it's prudent to state that your data is definitely going to be replicated into different availability zones. But as compared to one zone, data will only stick to one availability zone. So that's why we have one zone and one zone IA. Definitely, one zone IA is for data that you're not interacting with a lot, meaning that data that is infrequently accessed within your one zone storage class. So it's much more or less the same with what we have in Amazon S3 storage classes. Then as we transition to performance modes, we have 2 modes. One is the general purpose and we have the max IO. So the general purpose is mostly for just the normal workloads that you work with, the general workloads that you have. And we are saying that here you can leverage just most of your workloads. Are we together? Then we have max IO, which will incur some higher latency as compared to general purpose, because general purpose will have the least latency and will have moderate throughput. If you have a workload that requires moderate throughput, you're going to go for general purpose. But if you have workloads that really require a lot of throughput, a lot of such as big data, where you are reading into your big data, or you are writing into your big data, then definitely you're going to look for a performance mode that definitely has higher throughput, though you're going to compromise on latency a bit, but throughput is going to suffice in that case in terms of performance modes. So we are going to look at it, but we'll need to first of all understand from the theoretical aspects what all this is all about. Then throughput modes. We have provision throughput, and under provision throughput, we have elastic throughput. Are we together? So it's not like there are 3 of them. There are mostly 2. Provision throughput and bursting throughput, where elastic throughput is under provisioned throughput. So provision throughput and bursting throughput. Now, there are situations where you would want to you already know your workload. You already know the kind of workload that you have, and you already know the kind of throughput to expect, meaning that you have predicted workload. Then if you have predicted workload, then you can measure the amount of throughput that is needed that will still not impede your work as you're working. Therefore, we are saying that with provision throughput, you are able to specify what kind of throughput you will want for your workload. And if you don't want to explicitly state your throughput, then you can go for elastic throughput under provision throughput, where AWS are going to scale your throughput as your workload grows. Are we together? So that is under provision throughput. Then you have bursting throughput. You don't have to specify any throughput values for your workload. This is mostly for unpredictable workloads. You have workloads that have spiking. We will require some bit of throughput due to spikes in your workloads. Then throughput, bursting throughput will actually suffice in this case, because it's actually going to react with when you experience some short bursts of or when you require some short bursts of throughput with your workload, and it's going to intelligently provide enough throughput for you when there are spikes, and definitely lower throughput when there are no spikes. So that will be it on the bursting throughput. So I think before we get to the use cases, I think it will be prudent enough for us to go through the demo, unless probably there's a question before we proceed to the demo. Do we have a question? Okay. So allow me to go to the demo, where I'll first, before we even interact with the file system, I want us to look at the security groups that we have, because we'll first of all need to look at the security groups that we have. Then after that, we can look at where we are going to actually fix these security groups. So there are two sets of security groups that I've already created. So one is the EFS security group. So this security group is actually placed on your mount targets. So mount targets are ideally like endpoints for your EFS file system. So we'll need to secure it. Are you together? Because we are going to require two security groups. One is going to be on the EFS mount targets, and then we are also going to have a security group for your EC2 instances. So whatever we are saying is this: that for you to interact with your EFS file system, then you're going to need, or if traffic is already allowed into your instance, then let that traffic also be allowed to traverse all the way to your mount target within your EFS file system. So we are going to have to create that security group that is going to allow inbound traffic from your EC2 instances security group. And therefore, before we even start off with that, we are going to need the security group for our instances. So just to have a sneak peek of our inbound rules, I know by now we know how to probably check the inbound rules for your security groups. So instead of creating, let me just show you, because I've already created some of the posts that I've had to open for us to actually have that security group. So within our inbound rules, we are going to actually confirm that we have two rules. We have SSH and HTTP. But mostly what you're going to be using is SSH, and we're going to allow traffic, any kind of traffic, to traverse all the way to our EC2 instances. So we're going to create two EC2 instances that will allow SSH traffic and will allow HTTP traffic at the same time. So so that is on the security group for our EC2 instance. Then we have a second security group here, which is the Elastic File System security group, which is going to be there to safeguard our file system, which will allow us to determine what kind of traffic should be allowed to probably read into our file system or write into our file system. So if we investigate the inbound rules, we are going to notice that there's one specific protocol. We've said that EFS uses the NFS protocol version 4. So it's prudent that we basically open the NFS protocol under port 2049, and the source of traffic here should be the security group of our instance. Remember, we call this instance security group. So this term basically means that from the top, assuming that our security groups are at the top. I just want us to think of it literally. Yeah? So we have, at the top, we have our EC2 instances that are safeguarded by security groups. But then again, we'll need to have our traffic traverse all the way to our file system. So the security group of the EC2 instance needs to allow the traffic to move all the way to the EFS mount targets of our EFS file system. So that means that the security group of our file system needs to allow any traffic that is already accepted by the security group of our instances. And that's why we're having to explicitly state that traffic needs to come from the security group of our EC2 instance through the NFS protocol on port 2049. So once that is set up, so we know that anyone who will try to read into our Elastic file system or our EFS file system, then they'll have to traverse through the NFS protocol, which we know comes with the EFS file system. So once that has been set up, then we can go ahead and create our file system. Then after that, we're going to create our EC2 instances and then try to link them together. Then eventually for us to confirm if indeed we have a shared file system, we are going to create a directory in one of the EC2 instances. And then from the other EC2 instance, we are just going to be confirming whether whatever was created on one instance, whether it exists on the other instance. And thereby, we are going to confirm that indeed it's a shared network file system that the two EC2 instances can definitely read from. So let's go ahead and create our file system. So we can call our file system EFS. Let's call it file system. And then we do not have our own custom VPC set in place. So we are definitely going to work with the default VPC that has already been created for us. And you will see that AWS have simplified the creation of our file system. But for our case, we'll definitely go and customize just for us to see what are the other configurations that we can take advantage of. And that will warrant me to talk about these features that we've talked about here in terms of storage classes, performance modes, throughput modes, and yeah. So let's go and look at or investigate them. So under the file system type, we have regional or one zone. So this is where we have where we are supposed to actually choose whether we want it to be one zone or whether we want it to be regional. So for our case, we want it to be regional so that it can span across multiple availability zones. But if we were to go with one zone, then definitely we will have to select the availability zone within which we can have our EFS file system. But for this case, we can go with regional so that we get to mount our EFS file system onto all of the availability zones that we'll choose. Then after that, we also have the option to automate backups. So for this case, we're not going to automate backups, though you still need to automate backups if you're in a production environment. Then under lifecycle management, this is where we're able to perform intelligent tiering. Are we together? So we are saying, since we have EFS standard, which allows us to interact with the data that we use on a day-to-day basis, how long will we want to transition data into infrequent access if the data is not accessed within a specific period? So here we are saying that transition data after 30 days into infrequent access if that data is not accessed. Are we together? Then you can transition into an archive after 90 days, just like what we have in S3. Yeah, you get to choose that specific timeline. Minimum is 60 days, but you can transition all the way to an year of data not being accessed. Right together. So apart from that, we can look at encryption. Under encryption, we're able to see that you're able to encrypt data at rest. This is just some of the things. That's why we're saying that it's managed. So you don't get to do all the work in terms of encryption. Altogether, you just get to tick, and you also get to choose the type of encryption key that you want. Do you want to have your own keys? Do you want to have keys that are managed by AWS? So when it comes to encryption, you have that flexibility to choose the kind of encryption that you want. And on top of that, we have performance mode. We've talked about enhanced and bursting. And under enhanced, I said that we have elastic. So that's why I was saying that there are not 3 of them, but essentially we have 2 throughput modes, though elastic will still fall under enhanced. So with bursting, you'll realize that from the documentation, they're saying that it provides throughput that scales with the amount of storage for workloads with basic performance requirements. So whenever you have spikes, then EFS will try and improve throughput when there are spikes, and definitely go back to default when you don't have spikes that require lots of throughput. Then we have the enhanced mode under our throughput mode, which I've talked about, and we've said that you have the flexibility to have the elastic mode. Use this mode for workloads with unpredictable read and write or reads and writes. With elastic throughput, performance automatically scales with your workload activity, and you only pay for the throughput you use. Then under provision, this is where you get to choose the amount of throughput in megabytes, and I think someone talked about it earlier on, and we are able to definitely provision the kind of throughput we want for our writes and for our reads. So you can see that if we have a throughput of 25 megabytes per second, you'll see that the read throughput is 3 times what we have for our writes. Are we together? So you'll find that the throughput for our reads is actually higher than that of our writes. But for our case, we would want to just work with Elastic, where we don't need to work with the numbers, and we'll just let AWS scale it for us automatically without our intervention whenever our workload grows. So that is on the enhanced and bursting. So bursting is used probably when you don't have predictable workloads, and there are times when you're going to have spikes that will require a lot of your throughput. Then you're going to go for bursting. Enhanced, you have that flexibility of choosing what kind of throughput to work with if you have a predictable kind of workload where you can predict the amount of throughput that is required for your workloads. So here we're just going to go with the defaults and move. Then under additional settings, we have performance mode, where we have general purpose and max IO. So after creation of your file system, you can never edit the performance mode. You can edit your throughput mode, but you can never edit your performance modes. So that will be the difference with the two. So under provisioned, where you get to provision your own throughput, you are able to then configure max IO. Are you together? So with max IO, it's designed for high parallelized, sorry for my tongue there, parallelized workloads that can tolerate higher latencies. So with the general purpose performance mode is mostly for the normal workloads that you work with, but for max IO, if you're dealing with big data mostly, or you have AI ML trainings that you need to perform, then max IO would be best suited for that. But under Elastic, you'll notice that max IO is grayed out, meaning that you can't use the max IO mode under your Elastic option for your throughput modes. So here we're just going to do general purpose, which is the most recommended, which has the least latency, and it's used for a variety of workloads. Then you get to choose tagging, which you're not going to do, but you're still going to proceed. Then here is where we have something that's unique. So here we have all the availability zones. So I'm in the North Virginia region, and in the North Virginia region, we have 5 availability zones. So here you can specify where to mount your targets, and these mount targets are just like entry points to your file system. So you can decide to disable specific availability zones, so that if instances in those availability zones need not have to work with EFS, or or those specific availability zones do not have to basically interact with EFS, then you can disable or remove the entire mount target here in your list of availability zones. But if you intend to have all your availability zones have mount targets, then whenever you have instances in, let's say, US East 1, it's going to be connected to your EFS file system. If you have an instance in US East 1D, then you can definitely mount your EFS file system onto your EC2 instance, provided it's in the US East 1D. But if you remove it, then that means that you're not going to have your file system attached to your EC2 instance in this availability zone. So I want us to take note of the security group. It ends in 12C, because this is the security group that, and I want us just to go back. So you can see here, 12C, default. Though it's a default security group, I've manipulated it to allow traffic using the NFS protocol all the way into our mount targets. So this is the 912C security group is what is in our, is what is safeguarding our mount targets. Are we together? So 912C. So that's why it's here. So, but if you want to change it, you can always remove there, then choose a security group of your choice from your list of security groups, and we'll still work with the desired security group of your choice. So that means that our mount targets are secured by this security group that permits only traffic that is accepted by the security group of your EC2 instances. Are you together? And those EC2 instances are the ones that will need this shared network file system for whatever need, and you're going to confirm that. So once you've confirmed that the security group is indeed what is required, then after that, we are going to click next. And here you have an option to set a policy. So these are some of the common policies that are set up here, and you can also grant your own custom policies if need be. Do you want to prevent root access by default? Then you can always check this and you will see a policy editor getting generated here. Do you want to enforce read only by default so that only people can only read from the EFS file system and not write into it? You can set up a JSON policy for that. Do you want to prevent anonymous access onto your file system? Then you can always set up a policy for that. But for our case, I don't think we are going to work with any identity-based policy. And for that case, I'll just leave it blank. But you can always set up any kind of policy that you want. Even after setting up this policy, let's say you chose these two and decided to proceed. Then once your EFS file system is created, you can still come over here and edit this policy editor, or just edit your policy to capture whatever permissions you want for your EFS file system. But for this case, I don't want to create any policy, so I'll go ahead and click next, and just see a summary of your configurations, and finally you're going to have to create your file system. So with that said, we're going to give it some time for the file system to be created. And yeah, we can see that it has given us a success, meaning that our file system has been created. So within our file system, there are certain things that we can always investigate. So you will see here that, and I talked about it, the total size is 6 kilobytes. So that does not mean that the EFS file system just has a storage of 6 kilobytes. It's fully managed, meaning that storage is going to be increasing every time our workload increases. Are we together? Whenever we delete from our file system, storage decreases. That's how it definitely works. You're able to monitor a couple of things within your file system. You're able to monitor throughput utilization. You're able to look at the read writes that have happened per second. You're able to look at the throughput by type. You're able to look at IOPS utilization, client connection, storage bytes, all within your Elastic file system. And that's the beauty of EFS. Same, you're able to check on your file system policies. If you had created a policy, you're able to edit beforehand. Access points, networks, you're able to replicate your file system into different regions. Remember that it's a regional service. But if you want to replicate your EFS file system onto another region so that other EC2 instances can probably share data that is already in your EFS file system, then you can replicate your file system into a different region. It will still contain data that was in your primary region, and EC2 instances from that destination region can definitely check or can definitely interact with your file system. So that is under replication. So since you already have that, I think now the next thing we need to do, since we already have our file system in place, is to now go and create our EC2 instances, and then connect to our EC2 instances, and then mount our EFS file system onto the EC2 instances. So the next thing that you're going to do now is mounting our file system onto our EC2 instances. So now we are going to go to the EC2 service, where we are going to create our first virtual machine. So here we have the EC2 console, and inside the EC2 console, we are going to launch an instance. And I hope that you are familiar with the process of creating instances. So I'm going to launch 2 instances here. So number of instances, let them be 2, and then you're going to compare the 2 instances. Then just give them a name, instance, and I'm going to edit out. Or let me just state EFS EFS instance. Then probably we are going to work with the Amazon Linux 2023 AMI. I know we are familiar with the EC2 instance creation process. We are going to stick with the default instance type, which is a t2.micro. Then we'll need to work with a key pair. So I already have a key pair already set up for me. And that is going to be the EFS key. So this key is the one that is going to securely connect me to the EC2 instance. Then under network settings, I do not have a VPC, so I'll work with the default VPC that has been provided for us. No preference when it comes to the subnet. And definitely I'm going to auto-assign public IP, meaning that my EC2 instance is going to have an IP address or public IP address attached to it. Then remember we created security groups when we started off. So that means that we are going to select an existing security group. And remember we called our security group instance security group, which permits HTTP traffic and also SSH traffic. So we are going to check that box. Then once we are done with checking that box, meaning that our EC2 instance is now going to be safeguarded by this security group. Then from there, I think under advanced details, I don't think we're going to have any user data script that we're going to provision into our EC2 instance. Then we're going to launch our instances. So we have the two instances. So you will find that if you're dealing with thousands of EC2 instances probably in production, and those instances are probably web servers, instead of having to install web servers on individual EC2 instances, we can create an elastic file system. And then that elastic file system, which is EFS, will be mounted on all of these EC2 instances. But we can only have one script, or we can have all our files for our web servers being stored on the EFS file system. So meaning that the web server that we're going to work with are actually going to be hosted on the file system. And all the individual EC2 instances are going to be displaying their web servers from the EFS file system. That's a good use case of when you can use the EFS file system if you're dealing with Linux-based instances. So for our case, let's just see. Now we've already created the two instances. But once, this is where we are going to now do the comparisons. We are going to connect the two EC2 instances. So allow me to edit this, call it EFS instance 1, and then allow me to edit the second instance, and then call it instance 2. So now I have the two instances in place. So what the key takeaway in all this is, I am going to create a directory here called EFS in instance 1. I'm also going to create a directory on instance 2, also called EFS, in my home directory or in their home directories. Then once that is set up, I'll probably create some sample files onto EFS instance 1, and then we're going to confirm from EFS instance 2 whether those files exist. So if they exist, then that means that we have successfully mounted our EFS onto our EC2 instances. But before we do that, we are going to need to connect to our instance and mount the EFS file system onto our EC2 instances. So let's start by mounting. Do I have a question probably up to that point? Any questions before we do the mounting? Okay. So I'm in instance 1. So in instance 1, first and foremost, we're going to need a helper. AWS from the documentation, I don't want to go back to the documentation. From the documentation provided by AWS, there is a utility or a helper tool that is going to perform a number of tasks. Going to allow you to set up TLS connections. It's going to allow you to perform retries whenever there are issues with mounting without your intervention. It's going to ensure that it installs the NFS version 4 protocol within your system. So we are going to work with this utility called the, let me first of all sudo yum. For those who are not familiar with Linux, I'm just installing this tool called the Amazon EFS utils. So this is just a command for installing this helper tool, which is the EFS helper tool, to allow us to set up our file system or mount our file system onto our EC2 instance. So I'm just clicking yes to confirm everything. So now I have installed the helper tool. Now with the helper tool, I'm able to now launch a number of commands that will now allow me to now mount the file system onto the EC2 instance. So now the next thing is, I will go back to my EFS file system, and now I'll click on attach. Are you together? So I've already issued the command, I've already installed the helper tool that will now allow me to issue these commands. So where are those commands? So now I'm going to click on attach, and when I click attach, I'll see here mount via DNS. So there are two options, mounting via IP, and there's mounting via DNS. And since I already have my helper tool to help me do that, first and foremost, I'm going to have to create that shared directory. Before I even attach, let me first of all ensure that I have the shared directory. So I'm going to go to my initial instance, which is EFS instance 1, and within the home directory, because currently, if I issue this command called pwd, it's going to show me my present working directory. So right now I'm in the home EC2 user directory or /home/EC2 user directory. This is the directory that I'm in right now, and this is the symbol to show you where I'm at right now. So within this directory, I want to create a directory called EFS. So this directory, let me use the sudo command to authorize creating the directory. So that means that this directory that I have created inside /home/EC2 user will be our shared directory. Are you together? This directory will be shared between instance 1 and instance 2. So that means that I'll also go and connect to the other instance, which is instance 2, connect to it. Once I am connected to this EC2 instance, I'm also going to do the same thing. They'll need to share the same name so that the EFS file system will know where to mount the mount targets. So first and foremost, I'm going to also create a directory called EFS, just like what I have done in the previous EC2 instance. So you can confirm that indeed we have EFS inside the home directory. And therefore, I can still issue the same command of installing the helper tool or the EFS helper tool, which is called the EFS Amazon utils. And once I have installed the utility, then now I'm able to now attach the mount targets onto the EC2 instances. So let me first install the helper tool. And since I already have EFS in the home directory on both of the EC2 instances, now I can go ahead and attach from the EFS file system. I can now click attach and now fetch this command here. And this command now is going to perform the mounting. Are we together? So mount is a traditional command used in the bash shell. It's a bash shell command. So it already exists in the bash shell. So we are going to mount an EFS file system. Are you together? So we are going to mount a file system of type EFS. Are you together? And we are going to incorporate encryption, specifically TLS encryption. And by incorporating TLS, where do we incorporate TLS on? We are going to incorporate on this file system that ends with 997. And if we investigate, the file system that has 997 is already the file system that we are working with. So we are saying that mount an EFS type of file system with TLS encryption enabled on this file system, and which is going to be our mount directory. Then our mount directory is going to be EFS that we have created. If you've given it a different name, probably it's a specific type of directory. Maybe it's a shared directory called I don't know, any name you're going to provide, you're going to probably exchange EFS with that name. If the path is different, probably the path is in another Linux directory, such as the bin directory or any kind of directory that you want. Probably the temp directory, if it's a directory that you want to work temporarily as a team and then get rid of it after probably a day or so, we can probably have that path here, /temp/ any other name /EFS if you so wish. But this is basically stating the path for which to place the mount target. Are we together? So, or where to perform the mounting, where do we mount that file system? So it's going to be mounted in the EFS directory, which we have already created. So I'm going to go to both of my EC2 instances. So right now I'm in instance 2. And if I issue this command and it doesn't bring an error, it will show that things are okay. So let's wait. So by virtue of not bringing any error, then that shows that already my EFS file system has been mounted onto EFS instance 2 at this path called the EFS path. Same is going to happen for instance 1. I'm going to come over here and I'm going to mount my EC2 instance in this specific path called EFS. So that means now, since I'm on EFS instance 1, I can make a directory. Allow me to first of all move or change directories and go to the EFS directory. So right now I've moved from the home directory /home/EC2 user and I've gone to the EFS directory. So by virtue of me going to the EFS directory, now I can create a directory now. I'm just creating now a directory that we should expect to see on EFS instance 2. So mkdir user group. So we have a directory called user group, or let me use elevated permissions. So I have to use sudo, and I can as well probably just create a file and create a file called demo.txt. Probably I've forgotten to use sudo. So I've already created that and create another file called user group ug.txt. And therefore, I have a directory called user group, a file called demo.txt, and user group ug.txt inside the EFS directory. So if I go to, this is in instance 1. So let me go to instance 2 and see if indeed, if I go to the EFS directory, right now I'm in the EFS directory, if I'm able to list out the contents of whatever is in the EFS directory, now I can see the files that I had already created in EFS instance 1 now being seen on EFS instance 2. Remember, with EBS volumes, they are solely attached to one instance at a time, unless you detach it and attach it to another instance. But now we are having a capability of a file system where multiple EC2 instances, even thousands, can connect to the same EFS file system. And this is what we have done. So we have, we can clearly see. So I can also add a directory here, mkdir, mkdir, sorry, I've run out of words. User group 1. I need to use sudo. And if I go all the way now to EFS instance 1, and I list out the contents of the EFS directory, I can see we have user 1 directory added. So we are able to work on this shared file system or this shared network file system using the NFS protocol version 4 to have our instances share or connect to the same file system. Is it okay, my people? Have we now seen how EFS works and how we are able to leverage it being a shared location for our multiple EC2 instances? Yeah, so ideally that's how we connect to it. Then I think, do you have any questions probably on how EFS works? So this only works with Linux. So if you are to deploy Windows instances, we will not do this. Okay, so then let's finish up on the documentation. So documentation gives us a use case. So Amazon EFS is designed to provide performance for a broad spectrum of workloads and applications, including the following: home directories. file system for enterprise applications, application testing and development, database backups, web serving and content management. This is the use case I provided earlier, where you will have your web server, which is the /var/www/html, which is what is going to be displayed on your web browser. You can decide for it to be in your EFS file system and have multiple instances have their web servers from the Elastic file system. Media workflows, big data analytics, you can choose to have your data reside on that shared network file system. So this is the use case for it. Then we have an architecture here. I think we've almost done this architecture, but it's just that we have not created our own VPC to specify the public and private subnets, but we've used the default VPC. But in a nutshell, you've seen how we've incorporated Amazon EFS by creating mount targets within each EC2 instance and making sure that they are successfully mounted onto the EC2 instances. So all of this, I think we've talked about as I was taking you through it. So I'm not going to belabor so much on it, but probably to look at the key takeaways. So Amazon EFS provides file storage over a network. We've seen that. Amazon EFS is a fully managed file system storage service that uses the NFS protocol and uses Amazon EFS to support Linux-based workloads on AWS or on premises that require shared file system storage. So in the exam, anything to do with Linux or POXIS compliant system for not for high performance computing, but basically as a shared file system or network file system, then you're going to work with Amazon EFS. So that's what I had on Amazon EFS. So I think we can move on to the next part, which I think will only take 5 minutes because, like I said, Albert did all the work in terms of explaining Amazon FSx. And probably I have this chart here that I've been able to curate here. And probably we can look at the FSx types, then we can definitely call it a session. And here we have the different FSx types. These ones came, I think they came later on, because I remember back in the day I didn't have this. And as I was recertifying early this year, I saw them in the exam and I was like, hey, what is this? And therefore it is always a learning curve for us as well, especially those of us who certified a long time ago. Or am I wrong, Pauline? Did you interact with this back when you certified back in the day? Did you interacted with this? If Pauline is around.
I'm here. So
Yeah,
they were not in like 2021, but right now.
Yes.
They're
Yeah,
definitely.
so they were not there. Yeah, so we used to be crammers back in the day. So I remember seeing it in my certification, like, what is this? But let's look at them. So let's look at this chart. So we have FSx Windows for Windows file server. But before we even get to look at it, just like how EFS is a shared network file system, FSx is still a shared file system. But remember that EFS has some limitations. So FSx is there to bridge those limitations. So first of all, you're going to look at a shared file system for your Windows workloads. So remember that with FSx for EFS, we were traversing through the NFS protocol. So now we're having to traverse through the SMB protocol. So at the end of the day, so this is still file storage and mostly for Windows operating system. And therefore, we know that Windows, when it comes to file sharing, is mostly through SMB. For Linux, is mostly NFS. So the protocol used is SMB. So whenever you're creating security groups, you will have to specify the SMB protocol, unlike what we used where we had NFS. So it's backed by the Windows Server, optimized for Windows-based applications, and the typical use case is for home directories, Windows application shares, Active Directory integrations. So this is a typical use case for the FSx for Windows. Then we have FSx for Lustre. We have FSx for Lustre. So this is definitely going to operate on the Lustre protocol. So this is a different protocol. And just like Olu stated, it's mostly for high performance computing. So even as you're approaching the certification, whenever you see HPC or performance computing, or probably the question entails probably AI ML training, financial modeling, big data analytics, genomic research, anything that involves big data, then we are going to go for FSX for Lustre. And when we talk about Lustre, they'll also talk about high performance computing for Linux-based workloads. So for the crammers in the house, Lustre Linux, high performance computing, not EFS, but Lustre. Okay, so mostly for high performance computing. So between EFS and FSX for Lustre, I think now you know the distinction. Then we have the newer ones, FSX for NetApp ONTAP, backed by NetApp ONTAP storage operating system, and it supports both. These are file system protocols. These are file storage protocols where we have NFS and SMB, and here we have block storage protocol, which is the ISCSI. So this is a protocol used for block storage. So it supports both file and block storage protocols, and it's optimized for enterprise grade or hybrid cloud storage. Are you together? So whenever you want to integrate a shared file system between AWS and your hybrid storage and operate on all the three protocols, then you're going to go for NetApp ONTAP. Typical use case for database workloads, for virtualization on VMware, multi-protocol access, disaster recovery. We'll always leverage FSX for NetApp ONTAP. Then, as we conclude, we also have FSX for OpenZFS, backed by OpenZFS, and is optimized for Linux-based applications needing snapshots or clones, and it will operate on the NFS protocol. So this is purely for Linux-based applications. So I think NetApp ONTAP and OpenZFS, you'll see the distinction is that OpenZFS will only be for Linux-based workloads, but this will support both Linux, Windows, and also block storage protocols. So here we'll only have NFS protocol, and it's much more optimized for software as a service applications where you will need OpenZFS, container storage, backup, stroke restore, or heavy applications. So I think with this table, it's easier for you to probably just peruse through it before you get into the exam, just to know what is the distinction between the different FSX types, and also incorporate what Albert had taken you through. So I don't know if you have a question on the FSX types. Just remember, it's also a shared file system that goes beyond what EFS provides, and therefore FSX will be able to definitely work on that and work for either Windows, the Lustre protocol, ISCSI protocols, and all that. So do we have a question probably on the FSX types, and definitely on everything that I've presented, because this is all I had. I hopefully did not collide with what Albert was training, but rather complemented what Albert took you through. So we've covered file storage, we've covered block storage, and what other storage have we covered? I think those are majority of what we have covered. So any questions, any insights? At least I should hear from Olu. Olu can't be this silent. No, Olu needs to say something.
Morning, Anthony. I mean, this is. I mean, thank you very much, Anthony. I mean, what a beautiful session. You've
Yeah.
just did justice to it. I mean, just like I mean, Albert has had done.
Yeah.
So I mean, kudos to you. Thank you very much. This is not our session. I mean, we do have our own session Mondays, and I mean during the week.
Yeah.
This is Isaac session. That's why myself and Samuel we do keep quiet. I mean, so that
Yeah.
Isaac can I mean take over their sessions. We don't want we don't.
Yeah. Yeah. I think that is understood. Olu. I think I'll pass it back to Pauline if there are no questions. From my end, I think I love the grit, especially being a Saturday. I know Saturdays are meant for rest, but here we are today, and yeah, I'd want to probably say thank you to all of you, and I'll take it back to Pauline.
Okay, thank you so much, Anthony. Okay, Isaac, I'm also taking it back to you. I've realized always said we hijack your session, and I talk too much in this session.
No,
It's been made.
no,
I've
no,
been
no, no.
made
You
up.
don't hijack.
Uh,
You don't hijack it at all.
Okay, so you can take over making your announcements. I think today it's fine if we end like some 30 minutes earlier.
All right. Thank you so much, Pauline and Anthony. Thank you for that extension of what Albert had done earlier on. So, Pauline, to you, I think I need to touch base with Terrace after here to find out what will be. Are we continuing with storage for next class on Saturday?
Okay.
That Terrace communicated that plan to you or not yet?
Not yet.
All right. Okay. No worries. I'll get in touch with him after here. Then I shall be updating the team on what shall be covering this coming Saturday. That said, once again, thank you so much, Albert and Anthony. We really do appreciate for your time to share your knowledge with the community here in Uganda. We can't take that for granted. And Pauline, thank you so much for stepping in to moderate the session. I think that's it, unless there's any other AOB from any team member here. If no any other AOB, we can call it a day and look to having a great weekend upon us.
Thank you, everyone.
Okay, I think
Thank
that's
you.
it. And bye to everyone.
Thank you.
Nice weekend. Thank you all.
Okay.
Bye bye.
All right. Okay, bye.
Bye.